to talk about a few of the security measures we talked about last week, implementing them and seeing if you have the chops to defend your Dapp against a malicious attack. Okay, so without further ado, go for it, Luke.
All right, cool. Thanks, Nick. So I would say presentation is a bit of an overstatement. This is going to be pretty short. The goal here is to give you guys more time to actually be working on labs in class, because the last lectures that we've been doing have been kind of long on Thursdays. But yeah, so like Nick said, today's lab is going to be focused on smart contract security. So really quickly, what I'm going to do is just sort of do like a quick overview of some of the security topics that are relevant to the lab today that Akash discussed last Friday. And then we'll just jump right into the assignment. So the first topic here was unsigned integer overflow and underflow. So I mean, these figures I think really kind of say everything that you need to know, but the basic idea is that in Solidity, when you're dealing with unsigned integers, you risk running into runtime errors when you are overflowing Solidity from its maximum possible integer representation or underflowing 0 and trying to represent a negative number. Also, feel free to interrupt if you guys have any questions at any point about any of these topics. So, second topic is, oops, this is slightly cut off. I guess, I mean, it really doesn't matter. So, the idea is modifiers allow you to restrict access on functions. Restrict access in the sense that we can say who can call a function, under what state conditions on the contract a function can be called, maybe at what point in time a function in a contract can be called. So over here on the right side is an example of this, or how you would use a modifier, taken from the Solidity documentation. At the top you see this modifier is defined only with the modifier keyword. The body of the modifier specifies the condition under which this function change owner can be called. What's also important is that we include this syntax, the underscore followed by semicolon, which basically you can understand as the place where the remaining function, the actual body of change owner, is going to be sort of filled in and executed. So applying the modifier to change owner, the syntax is the function name, the visibility, new line, visibility, new line, any sort of custom modifier that you define. So, I mean, here the idea is that we're only allowing the current owner of a contract to change the owner of the contract. Okay, and so then this is the third topic of review, third and final topic of review. This will be probably the most important thing for finishing the lab that's assigned today. A fallback function is the single unnamed function in a contract, and so a fallback function is executed under two specific circumstances. The first would be if a contract is sent value without actually invoking a specific function in the contract. So for example, if I call some contract address .call.value and I send some ether to that contract, then the body of the fallback function is going to be executed. The second case is if I call some address of the contract followed by a function name in that contract that doesn't actually exist. So maybe I accidentally misspell the function name, or I'm trying to call something that the contract doesn't actually support or hasn't implemented. So for the case, in the case of this lab, what's important has to do with the fallback function payability. So there's a specific keyword that we want to add to our fallback function that says quite literally payable. And if the fallback function is labeled as payable, then in case number 1, when a contract tries to receive value, you aren't going to run into any errors. But if the fallback function isn't payable, and we try to send value to a contract without invoking a specific function, then the payment is going to fail. So So it's just reverted. It's like the ether is returned to the person who's calling or trying to make the payment. Let's see. So actually, okay, I think that's all I'm going to say about this for now. We're going to let you guys sign in early today. I can put this up again too, or actually here, I'm just going to skip forward and you guys can sign in after we talk about the lab. So the lab, your job for today's lab is to implement two different auction contracts. One of them is called good auction and one of them is called bad auction. Some of the code has already been implemented for you, and we've also written a robust testing suite. So bad auction, as the name might suggest, suffers from security vulnerabilities, specifically the 3 security vulnerabilities that I just reviewed. Some kind of unsigned integer arithmetic error, failure to limit function access using modifiers, and a vulnerability due to lack of fallback function payability. Good auction, on the other hand, is secure to these vulnerabilities. And so just like quickly as a hint for how you're going to approach this, at least implementing the good auction part, the problem with a fallback function not being payable is that sometimes smart contract programmers will write into their smart contract some kind of conditional that depends on the success or failure of a payment being completed successfully. So for example, there might be some state change that follows a reimbursement payment or something along those lines. But if that reimbursement payment is never executable because a contract's fallback function is not payable, then the corresponding state changes are never going to occur. So good auction basically adopts the idea is that when you implement good auction, you're going to adopt a different paradigm known as the pull paradigm, which basically says to all of the contracts, if you want to be reimbursed or get money from my contract, you need to explicitly ask me. And so then we separate the payment logic for introducing those reimbursements completely. We separate that completely from all other state changes that are required for the contract to function sort of business as usual. Again, there's going to be more specific details in the skeleton code comments. So here is the link to the repo. You guys can go on there. I'll leave that up for now, and then I'll pull the attendance form back up in a little while just because we do want you guys to stick around for a second and kind of work on this together. So feel free to shoot any questions at me now, or if you have questions throughout, Nick, Natalia, and I will all be here sort of just wandering around. So anyways, good luck.